All right, welcome back, everybody. Now we've got Evergreen Telemetry, presented by CEO Pete.secor and Toni Angres, the Director of Sales. Evergreen Telemetry is dedicated to doubling technician productivity in tab, HVAC, commissioning, and automation. Their wireless tools eliminate wires and tubes, making every job faster, easier, and safer in the most demanding environments. Toni and Pete, I will turn it over to you.
Thank you so much. And thank you to AABC, excuse me, for hosting. We appreciate it. Um, I'm Toni, I'm with Evergreen. I am going to let Pete, he's going to talk today about some of the latest products that we have for making your job faster, easier, and safer. And then once we cover all of our new products, we'll let you know what prizes we have to give away today. I'll let Pete take it away from here.
I'm proud of our products. The Risk Reporter saves you many steps. And we have capture hoods, lightweight capture hoods that hold themselves against the ceiling with a magnet. So what are we going to do next? How can we save you more time? How can we make your job faster and easier? So my engineers and I are taking a look at velocity. I'd like to talk about two different kinds of velocity. One is face velocity. So how can we improve and save you time with face velocity? This is a traditional face velocity grid. One drawback is the way that the standoffs work. So standoffs, if you want to change the standoffs, you have to unscrew the standoff and hopefully not lose it. Find the other one that's a little bit longer and screw it in. And do that 4 times, and then you're ready to go on to the next task. So what we've come up with is a new type of face velocity grid, a new type of standoff. First of all, it's color coded. Every inch is marked with a different color, and within every inch, there are 1/4 inch gradations here that are caught by a little mechanism. So the standoff never comes off the face velocity grid. And if I want to make an adjustment, I will push it in and you'll hear a click as it moves each 1/4 inch as it moves to the next setting. So that's a huge improvement in time and effort, and I think you're going to like it a lot. Also, you may not be able to tell it through the video, but it's far more rugged than the traditionals. And we've got this really cool articulating handle that allows you to get into difficult spaces. So think about that face velocity grid. Toni can set you up with a free field trial and give it a try. Let me set this over here. So what about duct velocity? Let's talk about duct velocity. I have 3 different ways of looking at duct velocity and trying to make your job faster and easier. One is what I call the guide lock. It's got 2 purposes. One is so that when you're doing a traverse, you'll be properly oriented and the tip won't be wavering around. But the other is, imagine that you are going to make a change to a fan or a damper in order to affect a change in the CFM. What you can do is set this up like this. I'll hold the duct up a little closer so you can see. Basically, set the probe up to get a center line of velocity. Now, the result is going to come to your wrist on the wrist reporter. Now, when you go over to the damper or the fan and you're going to make a change, let's say you want to reduce the CFM by 20%. What you can do as a reference is check out the velocity of the center line. And when that goes down by 20%, you're achieving roughly a 20% reduction in CFM. So you're just saving the back and forth. Now let's consider another way of saving time and effort is the probe itself. You know, it was invented a long time ago, but it still kind of looks to me like it's designed for use in a laboratory where you're going to, put it in a vise or a fixture and you're just going to leave it there. It's not really designed to be held by a human hand. And so let's give it a handle. Let's give it a handle. and make it more like a bicycle grip or a fishing pole. And just make it really easy for a human hand to control the rod, to control the tip, and put it where it needs to be. So this is our version of the airfoil velocity grid. These are available now. Let me set these over here.
Do you want to speak, Pete, to the notches in the airfoil?
Thank you. Toni reminded me to point out that first of all, the inch marks are very easy to see, and they're notched so that as you are doing a traverse, you get a little tactile feedback on from the edge of the duct interacting with the notch. Thanks, Toni.
Yeah.
Okay, let's see if you're ready for this one. This is a motorized machine that will automatically perform a duct traverse. And what you do is you attach it to the side of the duct, these magnets. I'll hold this up to the camera so you can see. So we've got a motor out here. It's gripping the shaft, and it knows where the shaft is. And it's wirelessly communicating with the controller on a tablet computer. This is a simulation. And before you get to this stage, basically, you do the setup and you tell the machine the size and shape of the duct and whether you want to use equal area or log Chebyshev. And then you hit start and the machine will perform the traverse for you. And this is one of the many views that you can select to see the progress. If you look at that kind of that diagonal, you'll see the green information coming in from a new reading, and the result in terms of average velocity and CFM will be shown. So, that, if you ask me, that's a revolutionary change. So the technician, basically, that's doing the work. He can be off drilling another hole, or getting ready to do a different duct system, or writing a report or something like that while the machine performs that traverse. I think the repeatability is going to be far better. You'll get more consistent readings, and of course you have the time savings. So those are some of the things that we're working on here. And thank you for your time. I look forward to your interest, and contact customer service if you would like to do a free field trial with these products. Thank you.
Hang on, Pete. Do you want to talk about Bluetooth? Where's Bluetooth?
Shoot, I'm always forgetting about Bluetooth. We have Bluetooth working actually. This application I just showed you is working via Bluetooth. We have Bluetooth working on the phone, but we want to perfect it. We're working with Building Start and Ameritech so that when we introduce this, those applications are going to be optimized. So it won't be long now. Thanks for your patience. Bluetooth from Evergreen Telemetry is almost here, and it's going to have that wow factor.
Yay!
Toni?
Thanks so much. Okay, guys, before we go into Q&A, I wanted to show you what we're giving away today. Today we're giving away, you're going to get a KTAB 7, which includes a wrist reporter, PVF module, thumb switch, charging capabilities, all of that in a nice hardcover case. You're also going to get one of our airfoils, our new Evergreen Telemetry airfoil, and a guide lock for your airfoil as well. So the lucky winner, please type Evergreen into the chat to be entered into the drawing, and you do have to be present to win. This is a little over about $3,500, a $3,500 value. So this is a great price. Or I'm sorry, great prize.
All right, thank you so much, Pete and Toni, for that demo and talking about some of your products. I want to remind everybody while you're entering Evergreen in the chat, send your questions as well for Pete and Toni. I'm sure they'd love to answer some questions about what Evergreen has going on. We have one question already asking, are magnets the only means for attachment of equipment to the ducts?
So magnets are used quite a bit because most of the ducts are ferrous metal, and the magnet can attach. It would be possible, however, to use either tape or sort of the type of strap that's used with the wrist reporter to wrap it around and hold something against the duct. I guess it would depend kind of on what the user is thinking about from the standpoint of what type of application, but we do use magnets quite a bit.
All right, thank you. This next question says, is there an option for correction factor and back pressure?
Yes, on our capture hoods especially, we offer a back pressure adjusted reading figure. And so that is available, yes. I might mention that back pressure is a complicated subject, and we might want to go into that in more detail on a future meeting.
All right, the next question says, do you offer linear attachments for lightweight flow hoods? If so, what sizes and are they magnetic?
Yes, the frames are all available with magnets, and we carry all of the standard sizes from, your 1x4, 2x4, 1x5. We also offer a 6-inch by 4-foot. If you're talking low flow, that would be more towards the 3-pounder, which it has a CFM range of 30 to 3,000. But if you're looking for lower than that, the 8-inch is 15 to 150, and that would get a little bit more custom. We do offer a 2x2, but it would be application dependent for other sizes.
And this is a good time to mention that we offer custom sizes. We need about 2 weeks to create the necessary frame and skirt, but we often do custom sizes. And our largest skirt so far, we do quite a few 4 feet by 4 feet for Intel for wafer fab applications. And I remember one time we did a 3-foot by 5-foot capture hood skirt frame combination. So we're very interested in doing the custom size if you have a unique application.
All right. And does Evergreen offer field trials or demos for companies that might be interested in testing your equipment?
Yes, we offer free field trial on all of our equipment. So it's a 2-week free trial. Give us a call, let us know what you're interested in. We'll ship out the equipment to you, let you try it in the field. We also offer demos or training. All of our training is free, whether it's via Zoom or a phone call or in person. We can come out and do some training or train the trainer with you. But the free field trial we do offer to everyone, and I highly recommend it to anybody that's interested in the equipment.
Yeah, that sounds like a great way to get a sense of what you're offering. This next person asks, do you have a hydronic manometer for water balancing?
Yes, we do, and it works in conjunction with the same wrist reporter that's used for the airside applications.
All right. We have a couple more minutes, so if anybody has any more questions for Toni and Pete, put those in the Q&A and we'll be happy to answer them. And just a reminder to everybody as you're entering the giveaway that we will announce that at the end of the whole show today after our final presenter. So stay tuned and we will get to some of these prizes. All right, one last question. This one says, is there a requirement for hood calibration or only wrist reporter?
The wrist reporter actually doesn't require recalibration. It's just the receiver. What needs calibration is the actual, the reading module. So the PVF module, we recommend every 2 years. Same with air temperature. If it's humidity or with the water, we do recommend annual calibration because those sensors do have a tendency to drift. But the capture hood itself doesn't perform a reading, so the hood does not need to be sent in for calibration, only the module.
Then we had another question come in about Bluetooth, and how testing Bluetooth works. Could you talk a little bit more about that?
So for 15 years now, our products have used a technology called Zigbee, a mesh networking technology. Bluetooth is a little bit newer. So we're in the process of converting our modules over to the Bluetooth technology in order that it can work more easily with cell phones, smartphones, tablet computers, and things like that. So we'll be offering both. And the coming of the Bluetooth offering from Evergreen Telemetry will not obsolete any of the products that the customers are currently using.
All right, thank you. A couple more questions coming in. This one says, do you have vane anemometer which can save velocity readings and show average?
No, we don't have a vane anemometer at the present time. I'm looking into either developing a vane anemometer for Evergreen Telemetry to manufacture, or to accomplish the same type of reading in a different way with a different technology that might offer superior features. So I am looking at that, but we don't have one at the present time.
All right, thank you. Next up, this one says, when measuring airflow and pressure at the same time with the wrist reporter, why would the airflow be displayed in uncorrected format?
So I'm trying to think back to that particular application. It might be for VAV type applications. And if that's a desirable quality, I can take another look at that. I honestly can't picture right now the display format for that, but I'll make a note. And if the interested party wants to give me an email at pete.secor at evergreentelemetry.com, I'll see what I can come up with.
When I think too, he might be asking just why are we showing corrected and uncorrected with a hood reading? So I don't know if that's more what he's looking for.
There is an applicable VAV where you want the pressure, differential pressure at the same time you're reading a flow. So that's where I thought the question was going.
I'm learning with you guys.
All right, one last question. What drift occurs that requires recalibration?
Okay, the easiest, most obvious example is the humidity sensor. We use a humidity sensor that's based on a capacitance between two plates. Obviously, these are small plates that are close together. And between the plates is a polymer. The polymer has holes in it into which the water vapor molecules migrate, and they change the capacitance. But what can happen over time is that contamination goes into the holes in the polymer and causes a change in the set point. So we have to be careful about that. Though that contamination can come from carpeting, paint, foam, rubber, things like that can off gas and create particles that affect that capacitive sensor. In fact, when those sensors are sent in for repair, we don't actually tweak it to accomplish a new reading or a new calibration. We actually pull the old used sensor out and throw it away, and we put a brand new one in that's factory fresh. And then we do our NIST traceable calibration to that and send it back out. So that's an example of the type of drift that can occur in a particular type of sensor. But as Toni mentioned, modern day sensors for temperature and pressure don't drift. So basically, if they haven't been damaged, they're going to read correctly.
All right, thank you so much, Pete and Toni, for being here today and answering those questions. If